Name is Neil Njoshampole, and I'm giving a project walkthrough of a machine learning system I created in order to determine the species of irises based on their properties. In this presentation, I'm going to explain to a degree the machine learning algorithm I used, and we'll do a code walkthrough and a demo. All right, so first let's take a look at the actual data. This is how the data is going to look. It's basically the properties of each flower: septal length, septal width, petal length, petal width, and species that it is. As you can see, we have different species here: Iris setosa, Iris versicolor, and Iris virginica. What we're going to do is feed it into something called a support vector machine, and which is a machine learning algorithm, and it's going to take the values of the actual petals or the flower, and it's going to determine the species of it. So we're going to separate the data into two sets: the training set and the test set, right? And by doing that, we're going to be able to train it on a subset of data, and with the actual test set, we're going to be able to determine whether it works because we already have the output values for it, right? So what is a support vector machine? So imagine every axis on a graph is a property of the flower, right? So we have one axis which is petal width, we have another axis which is petal length, we have another axis which is septal length, and another one that's the septal length, right? As you can imagine, graphs are only really good for up to around 3 axes. After that, it gets a bit more complicated. So what a support vector machine essentially does is it will create this in its computer world, and it'll be able to create an algorithm that'll actually take these points in this nth dimensional graph and separate it into groups, right? And based on those groups, it'll be able to determine the actual species of the iris. So we're going to take a look at the code right now. So here's the code. This is the Python code. I use Jupyter Notebook. Here I'm importing the libraries. Here I'm actually reading in the file. Here I'm separating it into inputs and outputs. And for the output, I'm changing it into numeric values because, as you can imagine, with any algorithm, it only works with numbers, right? So in order to train it, we're going to actually have to have the outputs as numbers as well, so the algorithm will be accurate, right? And then what I do is I actually split the data using this inbuilt function in Python, or this library we imported, and we're going to make the test size around 25% of the data, and it's going to pick the value separately, and it's going to create our training data sets as well as our test data sets, as well as it'll keep recorded the training and testing outputs, right? So what I do here is I create the model, I create an instance of it, and then I fit the model based on the values of the training data, so that it creates the proper values in the algorithm for it. And then based on the model fit, I am actually predicting the outputs for both, not just for the actual test data, for also the training data, right? To see how accurate the model will predict these things. Because remember, it doesn't just predict the values of outputs based on values it's seen. It could do it for things it hasn't seen. It's statistical, right? Consequently, what we're going to do, because we can't look at this manually, we're going to use a function in order to determine how accurately the predictions have done. So for the test data, it predicted the actual species with 100%, as you can see here. And then we also created a classification report, which uses other metrics to determine the accuracy of the model for the test data. Now for the training data, the accuracy was interestingly not as good, right? So it trained it because we don't want overfitting, because if it's too accurate, it won't work on oftentimes it won't work as well as on data it hasn't seen before. So here we created an accuracy score for the predicted values, and as you can see, it's around 99%, right? We created a classification report to see its accuracy there as well. And then we're actually going to run it again, right? So now we know our model works. Now we're going to try normalizing the data here, because what normalization does is it scales it to the actual same range, because if one property has much larger values than another and it's not normalized or scaled to similar ranges, what will happen is that it'll overwhelm the other data when it's training the model, and it won't be as accurate. So as you can see here, we're splitting it into our training and test data once again, and we're fitting the actual model, and then we're creating accuracy scores. And as you can see now, after we scaled it, our test data is one like before, but now our training data as well is showing us like 100%, and so it's working much better. So yeah, so this is a support vector machine that was able to predict accurately the actual species of irises based on the inputs, right? So I hope you enjoyed that, and this is introduction to my artificial intelligence journey project that I used to start it off or kick it off.